So in this video we're going to be discussing quadratic inequalities. They look very similar to what we had in the last section, but we're going to be using the quadratic part instead of the linear part. So what makes this a quadratic is this bit here, the x squared term. That's the quadratic part. The bx plus c, they're just usually extra bits added on at the end. But what makes it quadratic, as I've explained before, is the x squared is the highest power, so that means that this is a quadratic. Now, the only difference between the left-hand equation and the right-hand equation is this one is greater than or equal to 0, this one is less than or equal to 0, so it doesn't really make a difference. It's just a different way of writing it. Now, the first example we're going to do is as follows. X squared minus 2x minus 8 is less than or equal to 0. This is our first quadratic inequality. Now, what I would always recommend doing is, for these types of questions, when it says solve this, I would usually ignore this part for a minute. And I'll go back to that in a second. So, instead, I'm going to solve x squared minus 2x minus 8 equal to 0. Okay, we can deal with this part. We can put the inequality back in again in a second. I'm just going to solve this first. Now, again, using usual factorization rules, we can factorize this and we'd get x minus 4, x plus 2, which is, again, fairly easy, normal, fairly easy enough. We've done it before. That x, you go to case 1, case 2 then, x minus 4 equals 0, x equals 4, or x plus 2 equals 0, x equals minus 2. Now, these are our cutoff points. Okay, so these are our two roots. Now, to go back to this part, this is where the important bit comes in with these answers. So now, since I've solved this equation, I've got x equals 4 and x equals minus 2. I've just drawn a quick sketch of what this quadratic would look like. Now, I know it's a U-shaped graph because this x squared term is positive. It's a, like I said before, it's a hidden one. It's a kind of secret 1. So it's 1x squared. So because that's positive, it's a U-shaped graph. If it was negative, it would be an N-shaped graph. Now, because I've drawn a quick sketch of that, now I can relate back to what this question means. This quadratic is here, but this question means, when is this quadratic less than or equal to 0? Now, it's obviously equal to 0 at the roots, at this point and this point, but when is it less than 0? And it's less than 0 when it's under the line. So it's less than 0 between here and there. So to solve that inequality, it's all of the x's in between here. So my final answer would be minus 2 less than or equal to x less than or equal to 4. And this solution set is the answer for this question above. So just a quick recap on it. When you're given a quadratic inequality, ignore the inequality for a while. We can deal with that part afterwards. Just solve it as if it was equal to 0. So you get x equals 4 and x equals minus 2. Now you go back to this quadratic and you can draw it on the side if you want, or you can do it mentally in your head. You can draw a quick picture in your head of what you think it would look like. Just draw a quick sketch of it. And then that's where this inequality part is important. Is the function less than or equal to 0, or is it greater than or equal to 0? If it's less than or equal to 0, it's under the line, so it's between here and here. If it's greater than, so if it's going the other direction, if it's going this way, it would be the ones where it's above 0, so, or yeah, above the ground basically. So it would be all the numbers this way, which would be less than minus 2, and all the numbers this way, which would be greater than 4. So it just depends on what this inequality part is. So now the second question is a little bit trickier. It says find the range of values of k for which x squared plus k minus 4x plus k minus 1 equals 0 has real roots. Now this goes back to your understanding of the minus b formula. So again, because it's a quadratic, the minus b formula will work all the time. It will give you the roots. But the important part of this question is it says real roots. Now, for this equation above to have real roots, this part here, the b squared minus 4ac, that has to be positive. Well, it can be zeros actually. It has to be positive or equal to 0. Because if that is a minus number, that means you'll have a negative root, which means it'll be a complex, or sorry, you'll have a negative number which will lead it to a complex root, which makes it a bit awkward. So the main part we're looking for here is that this part in here underneath is positive or equal to 0. So this is actually our inequality part. Now, what's B, what's A, and what's C? You should know from your own understanding of quadratics that this is A, so it'll be 1x squared. This is B, and this part is C. So now what I'm going to do is put these letters into this formula. Okay? So now all I've done is taken A is 1, B is k minus 4, and C is k minus 1, and I've put those substitutions in here into this equation, the discriminant of the minus b formula. So I'm just going to work this out now. This expands to k squared minus 8k plus 16. Minus 4 by 1 is just minus 4, so that's okay, but they're all multiplied by everything inside. So minus 4 by 1 by k is minus 4k. Minus 4 by 1 by minus 1 is actually plus 4, greater than or equal to 0. Now clean this up a small bit. K squared is the only k term. Minus 8k minus 4k, that becomes minus 12k. 16 plus 4 is plus 20, greater than or equal to 0. Now, this is another quadratic, very similar to what we did just a couple of minutes ago in the other section. So what you do, as I've said a while ago, just ignore this inequality for a minute and deal with the question as if it's an equals. So I'm going to have k squared minus 12k plus 20 equals 0. So I'm going to try and find the roots first. Now, when you factorize that, it comes down to k minus 2 and k minus 10 equals 0. So that's just basic factorizing. That's okay. You should all be able to do that. Case 1 and case 2. Case 1 is when k minus 2 is equal to 0. So k equals 2. Case 2 is when k minus 10 equals 0. So k equals 10. So these are my two roots of this equation. Now, back to the step that we had again a second ago. This is my quadratic. I need to know when this is greater than, this whole equation here is greater than or equal to 0. So like the last example, just draw a quick sketch of it on the side of the page. One root is 2 and one root is 10, so it's going to look something like this. That's 2, that's 10. Now, it's a positive function because k squared is positive. It's not minus k squared, it's positive k squared. So it's a U graph. Comes down and back up. That's 2 and that's 10. Go back now to the inequality. It says, when is this function greater than or equal to 0? So obviously it's equal to 0 here and here, but it's greater than 0 when it's above the line. Now it's above the line this way and this way. Now to get those points, this value here, it's positive, that would be when k is equal to 0, that would be when k is equal to 1, k is equal to minus 1, minus 2, minus 3, etc, etc. And the same up here, 11, 12, 13. So this equation is positive, so it's greater than or equal to 0 when k is less than minus 2, sorry, less than or equal to minus 2, because it's all the numbers this way, sorry, positive 2, because it's positive 2 there. K is less than or equal to positive 2, or it's greater than or equal to 10. So this is my solution. So to go back up here, find the range of values of k for which this equation has real roots. this has real roots when k is less than or equal to 2 or when k is greater than or equal to 10. Because if it's between this section, this equation would be negative, which means this is negative, which means we have complex roots. Okay, so I hope that makes it a little bit easier and it makes a little bit more sense. I'll do more rational and irrational inequalities in the next video.